Okay, this is the P3 paper from October 2021. This is question number 7. It's an exponentials and logs question, and in particular, it's exponential modeling that we're looking at here. So, always good to read through the description. In this particular one, M is the mass in kilograms of a tree, where R is going to be the radius of the tree in centimeters. The first part says, well, we're given that for a particular tree, the radius is equal to 45. Can we find the mass? Yeah, absolutely we can. So let's just make a start to this. Part A, we've got log 10m equals 1.93 log to the base 10r plus 0.684. And they're telling me that R is equal to 45. So if R is equal to 45, let's sub that in. I'm going to get that log 10m equals 1.93 log to the base 10 45 plus 0.684. Well, yeah, that's fine because I can work out a value for all of that. So let's actually go ahead and do that on the calculator. I'm going to get that log 10m works out to be, just substitute it in, it comes out, I'm doing it as 3.8747, and now we're at the stage where if we have log a b equals c, we need to be able to change that to a power statement. Okay, and the power statement would be, in this particular case, that a to the power of c is equal to b. So if I do that over here, I'm going to get that m is equal to 10 to the power of this 3.8747. And then m will simply work out to be that evaluated, which I make 7493.766. And if we go back to the question says, yeah, good. The question says 2 significant figures. I was a little bit worried about how accurate to make that one there, but because it's 2 significant figures, pretty much any value I got is going to give me, yeah, in this case, 7,500 kilograms, I think it was. Let's just go back and check. Yeah, masses in kilograms. So relatively easy first part. Part B says show that this equation can be written in this format. Now, normally what we do is we start off with this and we end up getting that bit. And because I'm so used to doing that, I'm going to do that for this one here. So I'm almost going to do backwards of what they're asking me. They're saying show that this model can be used. Well, I'll start off with that being the model then. If m equals p r to the q, and the reason I'm doing this is because I do this in every other paper I've done so far, and it's just a really quick, straightforward thing once you get used to it. So what do we need to do? We need to log both sides, and they've told me to log it to the base 10 in the question. So I'll do log base 10 is log base 10 of this. And then using our log rules on the right-hand side, left-hand side doesn't change, but here I've got log AB. And I know that log AB is log A plus log B. So I can just use that log rule there to say that we've got log 10p plus log 10r to the q. And now we're also going to use the rule where I can take the power down. Do that on the next step. So we get log 10m equals log 10p, no changes with those, but now the q can come down there. And then if I compare that to what we had log 10m equals 0.684 plus 1.93 log 10r. So if we equate the coefficients here, I can see that value there and that value there are going to be the same. and I can say that the Q is going to be the same as that value there. Let's actually just do that now. So I say log 10p is equal to 0.684, and Q straight away, just Q is equal to 1.93. We've just done this one before previously with this base business. So this is P equals 10 to the 0.684, changing a log statement into a power statement. So that gives me P equals, if I work that out, 4.83. And again, go back and check, giving those to 3 significant figures. So I've done that. So the first 2 bits done. And then this last part, yeah, they quite often do one like this. With reference to the model, interpret the value of P. Let's just go back and have a look at what we've got here. So it really is a question with these last parts of looking at the question. M equals P R to the Q, and understanding that what I really want is for that bit to work out to be equal to 1. Okay, so I could say Q is equal to 0, which I've done in previous questions, but no, this time I'm going to set R equals 1, then I get M equals P1 to the Q. Now it doesn't matter what Q is, this is still going to work out to be equal to P, so M would work out to be P there, so this P is equal to the mass when the radius is equal to 1. That question is easier if you put it in conjunction with the other exponential modeling type questions. So go back and look at my channel, I've got other videos, search for exponential modeling, and you'll find other questions that are similar to that. It's only worth 1 mark, but it's a good mark to get, so hopefully that last part makes sense. The rest of it, relatively straightforward.